vectors. Generally in mechanics there are two type of quantities. One is scalar quantities and second one is vector quantities. So right now we are considering vector quantities for our study. So vector quantities are nothing but quantities that generally required two things to define it in a proper way, and that is magnitude as well as direction. So without two things we cannot define the quantity in a proper manner. So these are the main entity that will form a vector quantity. If we see the example of such vector quantities, so force, velocity, then moment, acceleration, displacement, these are the such example of vector quantities. Now generally a vector quantity that is defined with a small arrow based on its magnitude. So that arrow represents the magnitude of its vector quantity, and this arrowhead that presents or that will represent the direction of that vector quantity. Now they are generally symbolized with a bold small alphabet character, and it is used as a symbol with bar A when it is with absolute magnitude. Now it is possible that two vectors of same quantity, or you can say the same direction as well as the same magnitude, but the point of application are maybe a different, but this type of vectors are generally known as equal vectors. Equal vectors. Now maybe more than one or more than two vectors are required to sometimes addition or the subtractions. So there are basic operations are required to learn. So we can also easily add or subtract the vectors and find out the resultant vectors out of the available vectors. So let us see one by one operations. So first one we take, that is addition of vectors. Now when two vectors are required to added, so generally we use two methodology. So in first methodology, it is based on a law of parallelogram. Now let us consider two different vectors. So one vector is P and another vector that is Q with its magnitude as well as direction. So if you want to add these two vectors, so generally a summation of these two vector is p plus q is equal to r. So you can represent a p and q, both the vectors, as adjacent sides of a parallelogram, and that will be joined with parallel lines, and the summation of that, so this diagonal, that is actually represent a new vector. We can draw arrow here, so that is a new vector. So that will be a sum, or we can say the resultant of that vector p as well as q. Now it is also added using the second methodology, that is law of triangle. So this methodology is generally known as a very basic method or very generalized method, because in law of parallelogram there is the addition of only two vectors, but in law of triangle method we can add number of vectors. So let us consider here a p and q again. So with the two vectors p and q, let us we represent first vector p. Again you have to draw a q vector starting from the head of the p and ending up to the head of q, so with the proper magnitude of that particular vector, and again join with the tail of p and the head of that q with a vector or a new vector. So that vector is a summation vector of the vector p and the vector q. So maybe you can draw like this: q and p, and this one is the r. So this is p plus q and this is q plus p. So here p plus q and this is q plus p, but p plus q is equal to q plus p, and that equals to r. Now the triangle law may be extended to add more vectors, and it is generally defined by some notations. So if we write down that we have p plus q plus r, these are the three vectors, and the addition of that will be a new vector available, that is s. Further if we write, that is p plus q, that we take into bracket, that plus r is equal to, so p plus q we take as r dash plus r is equal to s. So this is a formation, r dash is a formation of the summation of p plus q. So then remaining is formation of p plus q, that is r dash plus r is equal to s. Alternatively you can also write down that p plus q in bracket q plus r is equal to p plus r double dash is equal to s. Now this is generally establishes the associative law of addition. Now how to draw that with different type of vector and come out with a new vector that is required to observe here. So if we take a vector p first, so with its magnitude value and the direction we can just show a p vector. So this is a tail and this is a head of p vector. Now we have another vector that is a q vector. So again start with its proper direction and magnitude. So this is a q vector, and then again we have another vector that is our r vector, and then at the end, so p, q and r, these are our basic vectors, and join that tail of p and the head of the last vector, that will be a resultant vector s. And here if we joining that, considering the different these alternatives, so this vector as well as this vector is our r dash and r double dash. So this is a methodology that we generally use if we want to add a number of vectors together. We also define the resultant of a system of vectors as a vector whose effect is the same as the total effect of all the vectors in a system. So here our S vector, that is that representing a total effect that is generated by a simultaneous application of P, Q as well as the R. Now second and the important thing, that is uh, subtraction of vectors. So in this, let us assume that we have a p and the q are the two vectors, and vector q is to be subtracted from vector p, or in other word we can add a negative vector q to vector p. Also we know that the negative vector of a given vector q is 1, that which has the same magnitude q but the direction opposite to that of the q. So we can write down, or we can subtract the vector q from the p. So this is our vector p, that is, and this is our q. So q is subtracted from the p, so that equals to, we can also write down in another way, that is p plus minus q. So we can change the sign, minus q, right? So that equals to, again graphically, this is p, this is with the alternative direction q, and again joining that, that is r. So here r is equal to p minus q. This is a subtraction of a vector. So here r is a new formation of the vector after subtracting vector q from vector p. Furthermore, third one, that is product of a vector and a scalar. Now here the product that we considered as NP. So considering the n as a positive integer and p as a vector having the same direction as p and the magnitude as np, thus a vector that is p plus p plus p that equals to 3p. 3p. So 3 is an integer value and p that is a vector with magnitude and the direction. So here we can tell that with direction of these three vectors that is given into this p vector. Also we can write down in form of m plus n p is equal to mp plus np. So different integer value with multiplying different vectors m p plus q that equals to mp plus mq, and m and p is equal to nmp is equal to m and p. So these are the different things that we can write down. So here m and the n, so summation of different integer value that is available with some vectors. So we can bifurcate here values with vectors, so mn plus np. Again we can write down m as an integer value that is associated with the summation of two vectors p and q. So we can write down with giving a proper integer value to each vector mp plus mq, and m and p. So this is a vector p with some integer value, and that is with some again an integer value. So you can write down like this or like this. Now again further important point, that is vector components. So we just write down here as a point D, vector components. The vectors whose summation is equal to vector p are known as the components of a vector p. So if we have different vectors, let us say vector a and vector b, so the summation of that vectors is equal to a vector p. So a and b, those are the components of vector p. Now if we take a different vector p, q and the r, so maybe higher than two vectors, that will also form a different vector components. So p plus q plus r, that will be also components of vector s. Now here we take in a graphical form. So let us take a first vector that is p1. So we generally define arrow here, and vector p2. So again we want to join that considering the parallelogram adjacent side. So here this is a p vector So we can say that uh, P1 and the P2 both are the component of this vector P. Now let us consider the xy plane. In that we have a vector P, and considering the components of that, having with theta as an inclination, we can just write down it is px, that equals to p cos theta, and here second component, that is py, that equals to p sin theta. So here p is one vector, and we take a orthogonal part of that two, that is px and py. So we can write down theta is equal to tan inverse of py by px. Also it is px and py are the components of vector p. So this is a vector component that we are generally used with its orthogonal way or non-orthogonal way. Now furthermore we considered next, that is dot products of vectors. Now in dot product, so name suggests that there will be a dot product of two vectors that defined as p into q, right? That also defined like this pq, and is a scalar quantity. So graphical representation of dot product, if we want to do so, that is in this way. So we have a vector here, that is a vector p, so we can represent as a p. Now perpendicular to that we put a vector q, and that is with some inclination at theta. So this component that is with q and the theta, that is q cos theta. And if you see here, a p is our vector, and we draw a parallel lines in direction with the q. So this is our q vector, this is inclination theta. So this component with respect to the p, that is p cos theta. So from the above figure we can write down that is q cos theta, that equals to q into p divided by q is equal to nqp. And secondly, from second part of figure, p cos theta is equal to pq divided by p is equal to NPQ, where NQ and NP, that is unit vectors of Q and P respectively. Also, there are component of any vector that in a given directions is the dot product of the vector with a unit vector in that particular direction. So from the definition we have the following such properties of the dot product, and that may be noted from the definition. So here the dot product is, we can say, the commutative, commutative, that is A into B is equal to B into A. That is also associative, so MA into NB is equal to MN A into B, and it is also distributive. So C in bracket A plus B, so you can write down C into A plus C into B. Furthermore, if we say that the dot products of two vectors is equal to the sum of the products of their respective scalar components. Now further we move ahead with a last important point, that is cross product of vector. So to define a cross product of vectors, if we take a vector P and Q, so it is generally represented by P cross Q, and that will be nothing but a new vector, that is vector V. So this another vector V whose magnitude is the product of the magnitudes of P and Q vectors and the sign of the smaller included angle, and whose direction and sense are such that the first vector, the second vector, and the product from a right-handed triangle. So now if we take a n as a unit vector in direction of the cross product vector V, so we can write down that V is equal to P cross Q is equal to PQ sine theta n. So and this is n is a unit vector when angle theta, that is more than 0 degree and less than the 180 degree. Now if the cross product of two vectors P and Q, that is represented graphically, so here that is a vector P, and this is a vector Q. Now if we make parallel lines to P and Q and find out the included angle, so that angle is theta angle, and out product of that p and q, that is another vector, that is vector v. And if we draw a vector q dash such that the heads of that q and q dash, that is parallel to the vector p, and this is a p into q. So we can write down that vector v is nothing but p into q, that equals to p into q dash. So p into q is area of this uh, parallelogram. So considering that the heads of that q and q dash are parallel to the p, so we can write down that the product v, that is p into q. So again, considering this and this, we can also write down that v is equal to p into q dash. And the direction of v, that can be determined by the right hand screw rule. Now note that p into q is equal to minus q into p. So if we draw that in the form of vector q and vector p with included angle theta and the product vector v, so that p into q, and if we change that direction of that vector v depending on the magnitude and direction of p and q, so that will be a minus q into p. Now based on the above result, we can say that the commutative law is not valid in cross product. A few more properties that are available, that the cross product may be stated in following way. So we can write down, if number one, if p and q are parallel or collinear. So p cross q, that equals to 0. Number 2, so we can write down cross product obeys distributive law. So example, we can write down that p, that is q1 plus q2 is equal to pq1 plus pq2. Third one, that is the cross product is non-associative. Non So as example, p multiplied by q multiplied by s is not equal to p multiplied by q into s. So these are the basic outcomes from the cross product of vectors. So this is all about vectors.